All right, so it is 1 o'clock. So as people continue to join, we'll go ahead and just get started. Want to welcome everyone. We're so glad that you could join us this afternoon. My name is Becca Quist, and I'll be acting as the host during this afternoon's workshop, but leaving it to the pros here on our panel to dive into our presentation information. This workshop is the second in a series of 3 identical workshops. There are opportunities for landowners and stakeholders like you to learn how the Kaweah Subbasin groundwater sustainability agencies are using the technology of LandIQ to measure evapotranspiration data at the farm level, and then how you all, the landowners and stakeholders, can manage your own ET data using a coming soon Kaweah Water Dashboard. So I just want to go over the agenda with everyone. We're going to kick off this workshop first with some Zoom logistics and introductions. Then we'll get into some of the content, starting off with a refresher on SGMA and some background on the Kaweah Subbasin, followed by an educational presentation on LandIQ. And finally, we'll close out with an introduction to the Kaweah Water Dashboard, which is that tool that I mentioned for landowners to visualize ET data and other key water use insights. And we do have time set aside this afternoon for Q&A. You can see it's the last thing on the agenda there, but I did want to let everyone know we will be stopping periodically after each presentation segment so we can address any questions that may come up during that specific topic. So like I mentioned, there is a team of pros on the webinar this afternoon, and I'd like to give them all the opportunity to introduce themselves, starting with Aaron.
Good morning, folks. Thank you for joining us today. We hope this is informational. We've got a great speaker for you, the guy that does the work for us and has developed a lot of the technology. So my name is Aaron Fukuda. I'm the interim general manager at the Mid-Kaweah GSA. And if there's any questions, I'm here during the presentation. Thank you.
Good afternoon. My name is Eric Osterling. I am the general manager of the Greater Kaweah GSA. And like Aaron said, we're here to hear your questions and concerns, and hopefully we can work through those things together.
Hi, Mike Hagman with East Kaweah GSA, Executive Director and also Manager at Linmore Irrigation District. Thank you for attending today. We hope it's helpful, and let us know if there's any information you need as we progress through this event. Thank you.
Hi, this is Joel Kimmelshoe. I'm with LandIQ, and I'll be giving a summary of the work that we do in determining field by field ET, evapotranspiration, how much water your crops use, as well as some other deliverables that we provide the 3 GSAs within the Kaweah Subbasin. I'll hold off on the descriptions of that for the presentation and let the introductions continue.
Awesome. Hi, everybody. My name is Savannah Chaden with Provo and Pritchard Consulting Group. I'm the product manager for the Kaweah Water Dashboard, and I'll be talking about what you guys can expect over the next couple months with the dashboard tool.
Hello, I am Trilby Barton. I'm with Provo and Pritchard Consulting Group, and I've been working with the East Kaweah GSA for the past several years, coordinating the outreach efforts. And as Becca mentioned earlier, I will be here to help you with any technical issues that you might have during the webinar.
Awesome. And as I mentioned earlier, my name is Becca Quist, and I'm with Provo and Pritchard as well as an external affairs specialist. I'm supporting the Kaweah Subbasin on this outreach. So happy to be here, and thank you so much, team, for those introductions. And before we get into our SGMA and Kaweah Subbasin overview, we want to take the opportunity to hear from you all in the audience, because so much of SGMA is about, and what we're doing here this afternoon is about engaging with landowners and stakeholders. And so to be effective at that, we want to provide you with relevant information here and in the future. So we'd just like to get an idea of who's joining us this afternoon. So you should see on your screen some poll questions. There's 2 simple questions that popped up, and just answer those, and we'll give folks about a minute here. If you don't see the poll questions, I know in the last webinar on Tuesday, some folks had a tough time finding those poll questions or answering. So if you want to still answer, you can use the chat. First question is, which best describes you? Landowner, grower, public agency representative, a farm manager. You can drop that in the chat. And the second question is, if you are a landowner or farm manager, what GSA do you operate in? Right, I'm going to go ahead and close out the poll here, share those results. So it looks like similar to the last webinar, majority of landowner growers here on the webinar this afternoon, but welcome to everyone, all the different representatives, and then majority East Kaweah, and then Greater Kaweah, Mid-Kaweah. So we have representation from all 3 of the GSAs, which is awesome. So I'm going to stop sharing those and hand it over to Eric, who is going to give us an overview on SGMA and the Kaweah Subbasin.
Okay, thank you, Becca. So we hope at least that you all are at least somewhat familiar with SGMA, but just in case you're not, I'm going to spend a little bit of time on giving you some background. SGMA 101, but I really want to keep this brief so we can get to the main event. Okay, so the Sustainable Groundwater Management Act became law in 2014. It was a multiple bill package that was signed by then Governor Brown, and it set in place this regulation that required a number of things that are going to be covered in these slides. It mandates that groundwater be sustainably managed by 2040, that local overlying land use and water agencies define what sustainable means, set certain goals and objectives, and then achieve them by that year. It grants local control to those agencies. So it's a little bit unique compared to the other 49 states in the union who also have similar legislation to manage their groundwater resource, that are local agencies that have historically managed the land use and the groundwater resource in the area, decide for themselves with their stakeholders' input how things are to be managed. Here's a brief look at the timeline and our major milestones that are needed to be met during the implementation period. Starting with in 2017, it was required that either these land use agencies and water agencies form groundwater sustainability agencies either on their own or collectively, and have complete coverage of the basins that were defined by the state needing to be covered. They could either do that on their own or collectively. In our case, in the Kaweah Subbasin, we have 3 GSAs that form joint powers agencies through joint powers agreements with counties, water districts, and cities and others in order to cover that. We needed to develop our groundwater sustainability plans by January of 2020. That's really our guiding document for each of us on laying out what the issue is and creating a path forward for our sustainability. We are now implementing our plans. So this is really part of it, is looking into our plans and what our path forward is and how to achieve that sustainability within 20 years. So we have to achieve that sustainability by the year 2040, in our case, in the Kaweah Subbasin. This is an overview of the Kaweah Subbasin. It's a 440,000 acre subbasin. The Greater Kaweah in green here is about half of that. The other 2 GSAs, East Kaweah in orangish yellow, and then Mid-Kaweah covering Tulare Irrigation District and the cities of Tulare and Visalia represent the balance. So groundwater conditions under SGMA. The Kaweah Subbasin is tasked with ensuring that this supply is available for years to come. It is not just a balance of our aquifer, it's also consideration of certain things that occur in a negative way as a result of pumping that are defined by the Act as undesirable results. But that balance side of things, our current target is about 80,000 acre feet of overdraft, similar to a bank account, that we're trying to rectify, and that is average annual. So bear in mind that that includes years of drought like we're in right now, and also wet years. So in wet years we see rebound in our groundwater aquifer, and in dry periods we see a significant deduction from that account. Sometimes it's significant, just south of 1 million acre feet. The groundwater sustainability plans, what's contained within them? Well, the first thing is that we had to define a physical description of our groundwater management areas, and then we had to create a water budget, like I just said, a bank account. The ins and the outs, that's all of the groundwater, tide, surface water, and rainfall, and all those things that are coming in and out of our groundwater aquifer. We have to monitor that and know exactly what's going on. There have been identified a number of data gaps, informational areas where we need to put in, for example, new monitoring wells. And then we have to define projects and management actions in order to achieve the sustainability objectives that we define within the plan. And that all has to occur within 20 years. And to measure our progress towards that, we've identified measurable objectives and thresholds. So measurable objectives, another way to describe that is that's where we want to be, versus our minimum thresholds are where we don't want to be. So the minimum thresholds are defined by the critical and negative impacts that would occur from pumping that we want to avoid. We have to report to the state annually in April every year, and a report is submitted. So we're preparing one of those right now to be submitted. And then every 5 years, the state does have an opportunity to provide us an evaluation, letting us know if we are seen in their view to be in compliance. So the immediate needs, that's why we're here. We want to accurately and efficiently understand the groundwater demand on an ongoing basis. We have thousands of wells within our subbasin that are all creating an impact or not to our sustainability objectives. And absent of having all of those wells metered, we're looking for an alternative that currently is LandIQ and using ET to evaluate that demand. And then we want to refine our water accounting mechanisms and refine our policies in order to connect with that understanding. And so some of the tools also are being developed, like the water dashboard that Becca mentioned, and it will be presented on later. It's the Q&A.
All right, so folks have a question. Again, you can use your Zoom menu and click on that Q&A button. We're monitoring to see if anything comes through. Alternatively, you can go ahead and raise your hand and we'll allow you to unmute and ask your question. We'll give folks just a little bit of time here. All right, Eric, your presentation was effective.
I nailed it. Okay.
No question. So if anyone thinks of anything later on, go ahead and pop that question in. We'll get to it. But for now, we did get a question, Eric. Who is the state, group, or organization that reviews each GSA office's data?
Great question. So that's the Department of Water Resources is the kind of first line in the state look at what we're doing. If we are within compliance, they assist us during that process, but if they deem us to be not in compliance, then they hand us over to the State Water Resources Control Board, which is a regulatory agency as opposed to DWR. And then what their function is to, in an interim fashion, manage the basin until we do achieve compliance. I hope that answers your question.
You got to think. So.
Okay, good.
The next question is, when will implementation begin?
Okay, so implementation has already begun. In the schedule, you would have seen that we had certain milestones, and so the first milestone was that we had to have full coverage with no overlaps and no gaps, covering the basin as local groundwater sustainability agencies by 2017. The second milestone was to develop our plans and submit those, adopt them by the year 2020, which we did. And so since January of 2020, we are implementing. And so to more clearly answer your question, it really depends on what part of implementation we are implementing. And currently, we are all pursuing groundwater pumping caps. So that is a big part of our ET interest that Joel will be presenting on, as well as other management actions and projects, which we have been in pursuit and successful in receiving grants to implement supply side solutions as well as demand. So we are putting in groundwater recharge projects as well. So we're doing a lot of implementation things right now, and so we are definitely in the throes of implementation right now.
Great. I think we'll get to this later on down the road, but someone asked, will the ET data be made public or will it only be available for landowners?
Yeah, why don't we save that one for a little bit later, but I appreciate the question.
All right, so I'm not seeing any other questions coming through at this time, but as I mentioned, at any time, please submit a question. Until that time, Joel, going to hand it over to you.
Thanks a lot, Becca. So I'm going to talk a little bit today about the work that we do for the 3 GSAs in the Kaweah Subbasin, as well as a number of other GSAs in determining field by field evapotranspiration. And we do that through heavy ground truthing. And you'll hear me say that term a lot of times in this little talk, because it's fundamental to capturing what's actually going on the surface of the ground, and then training our models for the purpose of mimicking elsewhere where we can apply those actual measurements on the ground. And also remotely sensed approaches, so we can cover the entire landscape that you can't necessarily do with boots on the ground. So I'm going to speak about the monthly field by field evapotranspiration, monthly field by field precipitation, and also land use that we deliver to each of the GSAs for the purposes of SGMA compliance that Eric was talking about. So just one slide on who we are. We started our little company in 2007 with 5 people. We're about 35 now. We purposefully developed our company with 2 main technical disciplines, that being land-based scientists, of which I am one, and about 80 to 90% of us that are land-based scientists are agricultural scientists. I grew up on my family farm in Butte County. My family still farms today. I spent 13 summers irrigating tree crops and row crops. I know exactly what's from literal boots on the ground, what's going on from an irrigated agricultural perspective. The other main technical discipline that we employ is folks are called spatial scientists, and those people generally specialized in remote sensing, looking at things from the sky with satellites, and then also GIS. GIS is a tool in which we use to manage spatial data. So think of Google Earth for agriculture, if you will. And then historically, we would roll out products in written form and reports and maps and PDFs and things like that. Now we roll out our results through a development team that posts it up to specific web pages that are interactive for the GSA managers and staff to look at all of the fields in their GSA, and I'll show you an example of that later. So we've been doing this work since about 2016. We started in Semi-Tropic Water Storage District, and it's just kind of grown since then. We do this, like I said, I've been doing this work since 2016. It's kind of a real passion for us. Fundamentally, we look at probably over 40 different crops. I say about multiple water sources, I mean, there really can be 3 or 4 different water sources. We measure water that is evapotranspired from agricultural fields independent of water source. So it can be rainfall, it can be surface water, it can be groundwater, it can even be recycled dairy water, for example. We produce, so that ET work supports multiple allocation methods. And each GSA kind of has, and subbasins kind of have their own way of looking at how they work with their growers on allocating how much groundwater they can pump or water they can use. But fundamental to any of those allocations is the ET work. How much water is actually leaving the system through the atmosphere, which is different. That's consumed water, and that's different than applied water. And I'll talk about that in a little bit. We produce monthly reports about 25 to 30 days after the end of the prior month. So it takes us about a month to do the analysis for the prior month. And then, as I mentioned, we integrate that to an online platform for people to view and interact and download the data. So I'm going to start off with land use. Now, this isn't ET. This is what crop is grown where. And I'm going to start off with that and just 2 or 3 slides about that, but I'm doing it on purpose. And the reason in just doing that is because, one, it gives an example of the term ground truthing and why that is really important. And 2, it's also a variable that we use as an input data into our analyses. So number 1, ground truthing. What do we do? Well, right now I'm sitting in Soledad, California with a ground truthing team, actually, I'll be honest, and we're driving up and down different roads in different places at different times, depending on what crops are grown, to capture a subset of the population, that being what's grown where. Why do we do that? And we do that about 15,000 miles a year, back and forth across the state of California, everywhere from Mexico to Oregon, Nevada to the Pacific Ocean. We do that to capture a subset of the total population to have a calibration point. We say, drive by, almonds left, walnuts right, alfalfa left, etc., and capture that on iPads as we go along. We do that so that we can have true calibration data for our remotely sensed models. Basically, we create a digital fingerprint of an almond orchard and a digital fingerprint of fallow ground and a digital fingerprint of pistachio orchard, you name it. And then we dust the rest of the crime scene, which is the area that we did not drive by. And that allows us to best match which fingerprint matches that field. We've been doing this since 2014 for the California Department of Water Resources. It was driven by SGMA compliant. They have to deliver land use to the GSAs. So we're the contractor that does that. Our accuracy is about 97.6%. So 97.6% of the time we get it right. How do we know we get it right? Because we ground truth. We say, what did we see versus what did we predict with our models? So that accuracy is there. When we don't get it right, we don't confuse almonds for carrots. We might confuse almonds for peaches, and both of those have very similar consumptive use or water use characteristics. And just a little tidbit of information, when we started doing this, the DWR also asked us to delineate out everything that was urban. So just the outer boundaries. It's not jurisdictional boundaries. It's just where urban ends and something else begins. And just an interesting tidbit of information that urban footprint in California is about 50% of the footprint of agriculture. And I thought it would be 20% or 25%, but it's a big footprint itself. So just as interesting point. Next slide, please. These are our accuracy matrices. Again, depending upon the year that we map, our accuracies are very high. These data are publicly available through 2018. We've delivered 2019, 2020, and are completing 2021. Those are all water years. So that's October 1 through September 30th. And they're very powerful data for people to make smart decisions on how land use is changing, especially when things might go fallow here. It's a way to kind of see the trends and locations and plan. It's a very, very important planning tool. So that was land use. Now I'm going to switch back over to ET. And I'm going to start off with the concept of applied versus consumed, or like sometimes I say received water. And when I say received, that's applied of irrigation, either groundwater, surface water, or recycled dairy water, and precipitation. And there's obviously irrigated fields that can have any component or of those three sources. And then also when we have non-irrigated fields, maybe some winter wheat or just some fallow fields, they receive a component of water too, albeit smaller in nature as compared to irrigated systems. The precipitation is very, very meaningful. So I'm going to focus on just a quick little example based on precipitation. So applied or received water is not the same as consumed water. Those are two different things. The difference is how efficient was that water used or consumed at that after it was applied or received. So evapotranspiration is simply the sum of evaporation, that water that leaves the surface of a leaf or the soil or something that it was applied to. It can be irrigation water or received from precipitation. And transpiration, which is the actual movement of water through the roots of a plant, up and through the plant and out the stomata on the leaves. So there's two pieces to it, and that is ET. Again, that's the consumed part, not the applied or received part, two different things. So, so what happens to the precip? We're gonna have a little bit of a demo here on based on precipitation in a fallow field. So what happens on a non-irrigated field? The only water that non-irrigated field sees, unless it has a high water table somewhere, but we'll just assume that's not the case, is precipitation. So what happens to that precipitation? It is either evapotranspired or either evaporated or transpirated, or what's left over may have passed the root zone and is non-recoverable or irrecoverable by the roots of the plant. So let's talk about a recently disked field. Evaporation occurs only from the soil surface. Let's assume there's no plants out there. So the only loss of that water can be evaporation. Rangeland, you can have both evaporation and transpiration. So how much ET water is left after ET? Well, it depends on how and when it rains. And we again measure, independent of water source, how much water leaves that system. And in all cases, your received water better be greater than your consumed water. Some will be stored in the soil profile, and some may, depending upon a really strong rainfall event, may pass water past the root zone and is irrecoverable. But back to groundwater. So let's assume a 20-acre field, and it rains 1.2 inches. We go ahead and measure from our monthly analysis on that 20-acre field about 1.75 acre feet of consumed water. That's the ET. So if you convert that 1.75 acre feet of consumed water back by dividing back through the acres, you get about 1.05 inches. So think about it again. 1.05 inches was consumed or evapotranspired, but that field actually received 1.2 inches of rain. So 88% of the water was gone. It's consumed. It's not remaining in the system. But only 12% of the water was not consumed. So what happens with that 12% of the water? It's either stored in the root zone for future use, and there's always a lag effect with irrigation or precipitation as to when that water is applied or received and when it's actually evapotranspired. Or it rained hard enough and in great enough amounts that it passed the root zone to groundwater. So the conclusion, at least on a non-irrigated field, and this is true for an irrigated field too, just because you have a certain amount of rainfall or received water or applied water doesn't mean you get to pump that much water either. There's a significant loss, and rainfall is a very inefficient application of water, if you think of it that way, because rainfall comes at the wrong time in our area when the plants don't use it, and it comes flashy and in small amounts that can evaporate very quickly. So back to ground truthing. What do we do? In our models for estimating ET on every single field, remember, we map every single field. We put a boundary around every single field's irrigated footprint. We classify for the crops what is crop is in that field with fairly high accuracies. We do that through driving and logging fields as we go along. But our ground truthing for ET is we have climatic stations that are out there. And these are surface renewal stations and eddy covariance stations. Those are fancy words, basically for measuring the parameters in a field to allow us to capture those necessary parameters to calculate actual ET of that field. If you do that enough times, you can then use that as kind of a fingerprint, like I said before in crop mapping. And that allows you to use that as calibration data for the models and also validation data in the back end. It's defensible. It avoids interpolation. Like, let's say we have 2 months of cloud cover. Wouldn't that be nice? And the satellites can't see through those clouds. We have actual on-the-ground measurements to allow us to see if temperatures were up, temperatures were down, wind speed was high or low, all of those parameters that influence ET. It also allows us the opportunity for continual improvement of our models and allows us, and really a powerful thing because we integrate in our crop mapping, allows us to do what we call crop-specific modeling. So we don't just model the lowest ET field and the highest ET field independent of crop type. We look at different crops. Like we have a citrus specific model, for example, and we look at fallow specifically and other crops specifically. That allows us to narrow that range of variability amongst the actual estimate. And those stations were developed in some past projects that we have done with DWR in the Delta and also with UC Davis researchers. We have a really strong public-private partnership with a number of folks. I'll introduce them in a second. And the unique thing about what we do from an ET, and because it's calibrated to ground truthing stations, it's truly a ground-up approach. Other remote sensing approaches look at a landscape from above, create a map of ET, and then chop it up into individual fields. We start at the field level. That allows us the most granularity in doing this. Ground truthing is harder. It takes more time. It can cost a little bit more, but the overall goal is to reduce the variability around that actual estimate so that you can manage your water as much as possible, but not too little and not too much. These are the same districts that I showed before, but the red dots in this map are where we have stations. And over the next 6 months, there's probably about 60 red dots or 70 red dots on this map right now. Over the next 6 months, our forecast is to have about 100 ground truthing stations in the South Valley, predominantly in Kings, Tulare, and Kern counties, a little bit up in Fresno. Again, we collaborate with UC Davis researchers and run some of their stations for them. They have a handful of stations, 3 or 4, and in exchange for the data. And we look at both irrigated and non-irrigated areas. Those stations also allow us to put rain gauges on each one of them. And we also instrument individual rain gauges in specific areas. I never dreamt that rain would make such a difference for growers. Every drop counts and rainfall counts too. So we've implemented a number of ground precipitation gauges, allows us to create a more thorough map of precipitation by field type. And it allows us to understand crop specific and repeated measurements. So we want to repeat in every good scientific experiment, you want repeatability of your measurements or repeatability of your results. And that's what those ground truthing stations allow us to do. So this is an example of North Kern Water Storage District area back from 2020. I could update these to 2021, but you get the idea. It's by month, January through December. The main ET months are shown there in the center. And you can see by the color gradation of the legend in the upper right-hand corner that where there are low ET months and low ET fields, some of those low ET fields in the middle of the summer may very well be fallow, or it might be an orchard that was pulled out, or it might be an abandoned field. There's a number of reasons why you could have low ET. And you can also see that a number of fields in the summertime has higher ET. So this gives you a visual interpretation or visual example of the results from an ET perspective. And these fields, although these are parcel boundaries that you see here, I want to stress that we actually digitize out the irrigated footprint of every field in California, and specifically in your area, of course, 2 acres and greater. So there is an irrigated footprint as well. So that was that first, previous slide was ET deliverable. Crop type is another deliverable. This slide gives you an idea of the extent of the same area, Hanford all the way, and Visalia Tulare all the way down to Bosco and Shafter. Same methodology that we use for DWR. When we deliver to them, we just do it much, much earlier and deliver it to each of the GSAs, so they have their crop type layer as well. I mentioned we have all those ground truthing stations with precipitation gauges on it. So think about a point of data that's captured, a point of information that's captured about precipitation in individual locations. We then can take all those points and kind of interpolate between points. It's called kriging. You can create a map like this. So this is the 2021 water year precipitation, and you'll see in some areas, way up in the northeastern part of the area that we analyze, some fields could have experienced as much as 12 inches of precipitation. In the western portion and in the southwestern portion of this area, it could be as low as 4.5. That's a big difference. Even though a small amount of precipitation, that's a big difference when you're talking about field by field water budgets. We also integrate in SIMA stations, airports, cities, et cetera, that we trust the data on, and to try to get as many points as possible. So think of it this way. Every field has ET. Every field has precipitation. Every field has crop type. And also, one more little benefit that we do this work too is, and we decided to deliver it to the GSAs, is for all permanent crops, we deliver each of those crops age. So we know where there's young orchards and where there's old orchards. And stands to reason that young orchards consume less water, smaller canopy versus a larger canopy of an older tree. So that too is another input variable to our models, all for the purposes of trying to reduce that variability around an actual number. If you have a variability of plus or minus 10%, and you can implement some of these ground truthing and other methods to reduce that plus or minus 10% to plus or minus 5%, that plus 5% on the top end and that plus 5 to 10% on the bottom end is meaningful water in 2 ways. One, if you're overestimating consumed water, that means you're not allowing your growers to pump as much as they could. So you ratchet them back. Basically, their allocations are lower because you're saying you're too high on your consumed water. If you're underestimating the ET, that means that you're allowing your growers to pump too much and you won't be in compliance with SGMA. So we want to continue to do as much as we can to narrow that margin of plus and minus or variability. We're never perfect. This is a natural system and there's always variability, but we've taken an approach at it to do the best job we can to try to collect the ground truthing data for calibration and validation of the models. I mentioned the online tool. I've shown you all of the spatial data. That spatial data is basically loaded up to an online tool with also downloadable buttons that can pull down the data and the reporting. Just an example, in the upper left is land use, same area, monthly ET for a specific month. And then on the online tool, you can click on any field, and there's a field in the center, upper part of that third picture. It's outlined in blue, and that is the ET distribution for that field. It's an almond orchard. We talk about its age. We talk about how much precipitation it received. It's all in the tool. So it's a nice, efficient way for the GSAs to get the data quickly. Everybody asks, how do you validate your results? Well, we validate them in a number of ways, some quantitative and some qualitative. And both are very important. We look at ground truthing. We talked about ground truthing. I won't go into that anymore, but if you can measure something on the ground, you can compare what you measure to what you predict. And that's an example in the lower left-hand part of this slide, that figure with the one-to-one line with all the points around the one-to-one. It's a measured versus predicted. And the closer you can coalesce those points on that one-to-one line, the better. Again, there's always variability in natural systems. That's the measured versus predicted. We've done extensive literature reviews. We know what the ranges should be on specific crops and what highs should be and lows should be and things like that. So we kind of look at it that way. Applied versus consumed. The figure on the upper left is 30 almond orchards. Age is on the bottom axis, and water is on the vertical axis. Green bars are the consumed water. The stacked blue bars are the sum of irrigation and precipitation. So again, received water better be above consumed water because nothing is 100% efficient. Lastly, we also very much like to work with growers. And if any of you want to work with us, we're happy to do that. If you have accurate pumping data, we always like to compare pump applied versus consumed. It's very important. And lastly, we have had some pretty good success, I'll have to say, with grower acceptance. And one example that I can give is that in semi-tropic, since we've been working down there since 2016 and kind of worked out the wrinkles over a couple of years with semi-tropic. Now, semi-tropic doesn't necessarily bill their growers on the acres irrigated, nor do they necessarily bill their growers on the amount of acre feet or CFS or of water that is delivered. They bill them on the water that's consumed. And that's really the water that leaves the system, right? Any excess water eventually will go back to groundwater or will be stored for future use. So if a grower's writing a check for a monthly amount of water and it's based on RET data and they're actually paying the bill, they know fairly well how much water they're consuming. So I kind of consider that a validation approach in itself. In addition to this, we want our results to be independently reviewed. Every month, Blake Sandin, a retired Kern County Cooperative Extension Agent, and Alan Fulton from Kings and Northern California County's Cooperative Extension Agent, both retired. I coerced them into looking at our monthly results every month. And we've really cherished their relationship and the comments that they provide us. In addition to Blake and Alan, we add a few more people 2 or 3 times a year. That's some folks out of UC Davis, Dan Howes out of Cal Poly ITRC, Khaled Bali from ANR, and then also a gentleman from the United Nations in Rome, Food and Agricultural Organization, all for the purposes of having an independent review panel to ask us hard questions, to curiously look at the data curiously, to see if it's lining up with what things people expect, to help us tweak our models when we need to do that. It's been a really valuable independent advisory group. Okay, that's it. So if you have any questions for me, I'm very open to attempting to answer them, and I'll pass off as many as I can to the GSA managers.
Yeah, so we'll go. Thanks, Joel. We'll go ahead and revisit the question. If one of the GSA managers would like to chime in on this one, it was the question about, will ET data be made public or will it only be available for landowners?
I can give it a shot. This is Hagman. The data we get from LandIQ will be reported at least annually through our annual report, and we are looking at possibly showing collective. Now, the data would be a collective approach. We'd show Kaweah Subbasin demand on fields over a period of time and present that on our, hopefully, the idea is to hopefully present that on our websites. But individual accounts won't be publicly available. Those will be managed by the GSA and between the GSA and the landowner.
I think what I'll add to that, which will be discussed later, is we do believe individual landowners will have access to their data via Water Dashboard, but that's a user login utility type information that's directly fed to the growers themselves.
Great, thanks, Mike and Aaron. A question for Joel. In your citrus model, do you have a range of values you use to check the applied water in ET? Can you share the estimate or range?
Yes, we do have a range of values, and that's a great question. We've been looking at that a good bit. We're actually embarking on a year-long study right now for exactly that same purpose, comparing applied water with consumed water in a variety of citrus groves in the East Kaweah and also in eastern Tule, who we work for. So that kind of citrus belt along the eastern side of the valley. Citrus is a little bit more variable, I'll be honest, than are deciduous tree crops like almonds, walnuts, pistachios. It's variable because there are a lot more varieties. There are a lot different densities of plantings. So think about number of trees per acre. And that's exactly what this year-long study that we're embarking on now with the Eastern Tule GSA and some other growers is intended to answer. And all for the purpose of refining our models as we move forward. So yes, we do have a range, and we have that because we know it's a citrus grove, because we map it, and because we know the age of it, because we do that too via remote sensing. We know that range by age, and so we're doing some crowdsourcing right now and pulling in what variety those citrus trees are, and we also are doing a remotely sensed approach and looking at that we did for the California Prune Board and looking at the density of trees per acre. And again, if you can capture those variables, you can integrate those into the modeling to reduce the variability of the output. So yes.
Thanks, Joel. The next question is, if a grower is using deficit irrigation to lower his ET, can the model detect this lower amount?
Yes, the model can. That's a beautiful thing about remote sensing. Prior to remote sensing, the main mechanism of estimating ET from a field was the KC approach, which is an empirical approach. So you have a reference crop ET that is usually taken from SIMA stations and a KC or a multiplier based on crop type that when you multiply the two together, you get crop ET. And every almond orchard would be the same. Every citrus grove would be the same because you're always using the same KC. Remote sensing allows you to look at every single individual field and a range of ET across the field. So if you're deficit irrigating, we will pick that up, and it'll show. If you have two blocks right next to each other and deficit irrigate one and not the other, we will see a difference, and we do. And we're working with a number of growers exactly in that capacity. This last year, we also worked for the Almond Board of California and mapped their almonds for them twice a year. And this last year, in 2021, they said, okay, now we want you to map the abandoned orchards in addition to just the acreage and the age, and also the stressed orchards. So we see that with remote sensing, and also we also see that when we're estimating ET by field.
So this next one, I'm going to punt over to Aaron. Question from Bill: how are we going to manage the application of water with a 30-day lag in reporting?
Yeah, Bill, great question, and thank you for putting that forth. It's one of the issues that we're solving through the use of our water dashboard. So Joel's product comes to us 30 days late. However, we should have it uploaded into the water dashboard. And I think over time, growers will become accustomed to the historical monthly patterns. And it'll be mostly a check on their prior year's usage. Now, this first year, you will have to wait 30 days to get, for instance, if you want your June evapotranspiration data, we get it in around the 3rd to 4th week of July, and we should get it up there by the beginning of August. So it is a little bit of a retrospective look at your ET, but you can track it as you move along. Specifically within the Mid-Kaweah GSA, we're not billing landowners in monthly time steps. Or looking at it in monthly time steps. We're looking at the beginning of the year and the end of the year. So we'll do an invoice at the beginning of the year and then a true up at the end of the year. I hope that answers your question.
Well, if I can, I'll add something to that. The results that we deliver are not intended for irrigation scheduling. They're intended for a kind of broader based water management. Irrigation scheduling, you're right, Bill. You'd need results a lot quicker to make a decision on irrigation scheduling. If you turn on or not, how long you're going to run it. that's not the purpose of the work that we do. But you can track your water, obviously, through a number of months. And if you in the future are, have an allocation you have to meet, that allows you to track where you are in relation to your allocation.
Great. Thanks, Aaron and Joel. Another question for Joel. How often are readings being taken? Does it make a difference if a grower is actively irrigating or is super dry during the time of your reading?
The measurements from the stations that we're actually taking in our ground truthing stations are every 15 to 30 minutes. We roll those up to a monthly number. So if a grower decides to actively irrigate or deficit irrigate, our measurements are basically continuous. So we'll see that happening, and our models allow us to pick that up. If you deficit irrigate, but yet prior to deficit irrigating, you had a lot of water in the soil profile, you may not see, and you probably won't see, an impact of that deficit irrigation for a little while until the trees or the crop that's being grown there mine what water is stored in that reservoir as the soil profile, and then say, oh my gosh, I don't have as much here anymore. And therefore, you'll start to see a reduction in ET. So there's always this lag effect. Keep that in mind.
Okay, Joel. So this is a bit of a longer question. So I know you're on your cell phone, but I'm going to go ahead and read it back to you. It appears the ET method does not recognize varying irrigation efficiencies. The operation that invests in more efficient irrigation management is not rewarded for pumping less water. In East Kaweah, we are told it is because the inefficient applied water simply returns to groundwater, which is 200 feet down through multiple pan layers. Is this an accurate observation?
So thanks for the question, Richard. It's a good one. Again, this gets back to applied versus consumed. We measure the consumed amount. The applied amount is what you're pumping, right? So it's same type of thing. So the difference is your irrigation efficiency. So if you're a higher efficiency water manager, let's say you're 90% efficient, and let's say you have two blocks, and on one you're 90% efficient, and on another block you're 80% efficient. Well, to meet the demand of those two blocks, and they're completely the same, everything else is the same, which never happens, but let's just assume that. If both of those blocks are the same, then you're going to pump more water under the 80% efficient block out of groundwater, thus reducing your allocation than you would if you were on the 90% efficient block. To meet the demand of each of those blocks, we'll assume that they're the same. So it is a benefit to be more efficient. That allows you don't pump quite as much, but if you manage your water appropriately, you're not shorting your trees for the consumed amount. You're reducing the amount that you're actually pumping. So it isn't a penalty, actually. And I can't speak to the East Kaweah one. Maybe Mike can speak to that one.
Yeah, real briefly, the water that is consumed, meaning the water that leaves the ground, that the efficiency of that, let's say you apply 100 acre feet and we see 80 acre feet leave the ground, the balance of that water against your applied will have to return to the ground. It doesn't leave the basin. It goes back into the ground. And maybe there's a misunderstanding about what that is, but the idea is to pump the right amount of water and become efficient. The more efficient we can become, the less water obviously you're pumping or demanding from your surface flow.
All right. Thanks, Mike. Thank you, Joel. I'm not seeing any more questions coming through at this time, but you never know. Like last time, someone may be typing away, so we'll give them just a little bit of time before we move on. All right. Still not seeing any questions, but as always, if something comes up, feel free to drop those questions in. We'll address them. But for now, I'm going to pass it over to Savannah to talk about the Kaweah Water Dashboard.
Awesome. Thanks, Becca. So I'm going to cover why the GSAs are building the dashboard, what the need is there. I'm going to talk a little bit about the roadmap. So where the water dashboard is going to go over the next year or so. I'm going to talk about the process we're using to develop the water dashboard, and then what you as landowners can expect specifically over the next 4 months. All right, so currently the need for the tool is that we have no tool that exists for landowners and the Kaweah Subbasin GSAs to easily share up-to-date water use information within the context of SGMA. And this makes quantifying and efficiently responding to groundwater use difficult. And I want to be clear that this information sharing is on both sides. So for the GSA perspective, they need to be able to have the information to inform policymaking and set allocations. And then the landowners also need to be able to see what their usage information is and be able to respond to the GSA policies. So what's really important for us to understand when we start a new project like the water dashboard is at the center of the circle. And that's why we're building it in the first place, what the purpose is. And then moving out from there, we want to understand the how. So this is the process or the steps that the GSA is going to be taking in order to achieve that why, that vision. And then the what is the water dashboard. And that's the tool that we're going to use to support the implementation of the how to help us get back to that why. So what's happening in the Kaweah Subbasin with the water dashboard, why we're building it, the purpose is to achieve the groundwater sustainability targets under SGMA while providing groundwater and surface water flexibility to preserve existing economies. And that's the why from the GSA perspective. And how the GSA is planning to provide that flexibility while meeting sustainability targets is through managing long-term water demand and availability, providing landowners with information to strategically respond to new constraints on groundwater, and for allowing that for that easy information sharing between landowners and their GSA. So that's being able to view your information, track where you're at, respond to that information, and manage your billing between the GSA. And the tools that are going to help us do that are the water dashboard. All right, so the ultimate value of the water dashboard for growers and landowners in the subbasin is that this tool is going to empower you to strategically respond to SGMA. It's going to deliver key water use insights at the farm level, and it's also there to track owner-specific water accounting and invoicing associated with SGMA compliance. So the dashboard is really only a success if it helps the GSAs reach their goal of achieving those sustainability targets while providing flexibility to preserve existing economies. That's the why we're building the dashboard. And these are the development principles that we're using to help guide us towards success. So we're starting with a phased development process, which means it's an ongoing process. And this gives us time to learn from users and from previous phases to help build a better product moving forward and inform policymaking. We're also taking a user-centered approach to development. So this means that landowner engagement is one of the primary focuses for us. We want to make sure that the tools we're building suit local landowner needs. And this also means that we're considering a diverse array of farm company structures to make sure that we can onboard all the different types of landowners in the subbasin. All right, so the product roadmap is a tool that we use to communicate how the dashboard is going to evolve over time since we're doing this phased development. We have 3 major phases of development right now that we've planned for. The first phase is all about viewing historical ET data. The second phase is about setting up a landowner water bank account. And then the third phase is looking at water trading. And each of these phases have different goals. So for the phase 1, the goal for the landowners is to be able to understand ET data in the context of your farming operations and groundwater pumping. And for the GSAs, the goal of this phase 1 is that the tool will help them register their GSA members and also be able to start to track who has what and where within their GSA. Moving into phase 2, this land water bank account, the goal of the platform is for landowners to be able to actively and efficiently manage groundwater and surface water supplies within the context of SGMA. And then the goal from the GSA perspective is that the water dashboard will support full accounting of water in the subbasin and billing for groundwater. And then phase 3, looking at this water trading phase, the goal is for landowners to have maximum profitability and to be able to optimize long-term asset planning with the information available through the dashboard. And then the goal of phase 3 from the GSA perspective is that the dashboard will help the GSAs provide maximum flexibility to landowners while still being able to achieve those sustainable groundwater usage targets. So the process that we're using to develop each phase of the dashboard is often referred to as a double diamond. So on the left side, the diamond there is all about understanding the problem space. And then the right side of the diamond is all about building a solution that works for folks. So it starts with understanding and defining the problem and then moving into that design and testing phase to identify what works best. And we really do engage landowners at all stages of the development process. So the way that this worked with our phase 1 release for the water dashboard is that we started with interviews in this sort of discover phase all the way on the left there at the beginning of the problem space. And here our goal was to really understand how landowners are using ET data now and how they're managing their water. And then from those interviews, we were able to identify some of the problems around how we could deliver the LandIQ ET data to folks in a way that's really actionable and works with how they're doing things right now. And that moved us into this sort of problem definition and starting to think about solution space, so the middle of that diamond. And here we worked to engage landowners in focus groups and using follow-up question and answer sessions with folks that we'd already interviewed, really trying to make sure that we really understood the problem here and that we were starting to build solutions that made sense. And then starting in the next week or so, we're going to be moving into our testing phase. And this is where we present the solutions that we decided upon based on landowner feedback. And then we really make sure that we're listening to see if we got things right, using landowner feedback from the testing phase to improve the product before it goes out for general release. So Becca is now going to switch over to a live poll. And if you are interested in working with our team at all to help make the water dashboard a better tool for everybody, I would encourage you to sign up for our user feedback group, which you'll have the opportunity to do in just a moment.
All right, so I've launched the poll, so folks should be seeing it. Should have popped up on your screen. But again, like I mentioned the last time, some folks were having issues in the last webinar accessing the poll. So if you are interested in joining that group of landowners that Savannah mentioned on providing feedback and staying engaged on the dashboard development process, you can drop your name, email, contact information into the chat, and we'll be sure to capture that. So I can see folks are responding now, but I'm going to give folks a little more time on this one, more questions. They might have to think a little bit harder. All right, if you're still waffling on yes or no, maybe, now's the time. Submit your answer. You can always change your mind later, but I'm going to go ahead and end the poll here, share the results with everyone. All right, looks like strong majority plans on creating an account of our poll participants. Some are still on the fence there. Appreciate everyone for filling this out. This is really helpful for us too, especially that second question, just to understand where everyone is at and what they're thinking about the dashboard, and just helps us plan better and do our outreach better, and then help Savannah, guide this development process more effectively. So thank you all so much for participating in the poll. I'm gonna go ahead and stop sharing those answers and then give it back to Savannah to finish out with the timeline.
Awesome, thanks Becca. And yeah, thanks for everybody for filling out that survey. It's really helpful feedback for us. All right, so I want to just quickly touch on what landowners can expect over the next 4 months here as we move into the phase 1 launch of the water dashboard. So right now we're in March and we're doing these LandIQ workshops and starting to introduce the water dashboard. In May, we will be releasing the phase 1 version of the water dashboard. So again, that's a space where landowners can create their accounts and view their historical ET data from LandIQ. And we'll also be hosting landowner registration events here to help get folks signed up. In the May through June timeframe, we're thinking about having these Kaweah Water Dashboard workshops where we can help people process some of the data in their dashboard account. And then throughout the summer, we'll be working with landowners from that feedback group and continuing the water dashboard development through phase 2. So as soon as we've got phase 1 out the door, we're going to get everybody's feedback on that, and we're going to use that to keep moving forward into that water bank account phase 2 stage. So, all right, so what specifically can you expect from the May release? Again, this is the phase 1 release that's focused on making sure that landowners can understand their historical LandIQ and ET data in the context of SGMA and groundwater pumping. So you'll be able to create a user profile on the water dashboard, and from there you'll be able to view all the data from all 3 GSAs in a single location. And then we've got some ways for you to view and interact with historical LandIQ data. So first off, looking at the average ET by crop type. We'll also have a way for you to view the total annual and total monthly usage for all of the land under your control. And you'll be able to compare that to what the groundwater allocation is for each GSA. And then we also have a way for you to track annual and monthly usage for individual parcels under your control. So you can kind of see how an individual parcel has behaved over a couple years, or you can just look at it throughout this year or last year. And then, so then you'll have the way to view your groundwater allocations based on which GSA that parcel is in. So with that, I think we actually move into Q&A. But if you didn't get a chance to fill out the poll, but you're still interested in joining the user feedback group, or now that you've seen that timeline, you want to change your answer to come join us, feel free to just drop your email in the chat, and we'll be following up with a survey after next week's live presentation to get in touch with folks again. Thank you.
All right. Thanks, Savannah. So I think that you kind of covered this, especially for this phase 1, but someone asked, what is the timing in implementing the phases in the dashboard?
That's a good question. Phase 1 is being released in May, and then the phases beyond that sort of depend on the policies of the GSAs and where different folks are at. But I think we're looking at phase 2 ahead of the beginning of this water year. And then phase 3, don't have an answer for you.
All right. So I see there's a question on the LandIQ. We're going to come back to that since Savannah's talking about the dashboard now. Just going to skip over to this next dashboard question, but we will get back to the LandIQ question. But Savannah, Roger asked, how many examples from other countries have you used to guide your process?
That's a great question. We actually haven't used data or examples from other countries right now. We're really focusing on making sure that we're tailoring the water dashboard to local landowner needs, but we are using best practices that are out there, industry standard for the development process and user experience.
Okay, Joel, we're calling you back into the ring. So someone asked on the LandIQ slideshow, can the math on consumptive use versus precipitation be explained more? And I'll try to go back in these slides to find where this is done.
Yeah, I can. Can you hear me? Okay.
I can, yes.
Okay. Yeah, I can explain it. I could have done a better job during the presentation. Sorry about that. It was just a kind of an example of the difference between applied and consumed. And in this case, it was a fallow field, and applied was rainfall. That's the water it received. So we had a 20-acre field, and during that month, It rained, and it was a heavy rainfall month. It rained 1.2 inches. And during that same month, or the time frame in which that rainfall occurred, we measured 1.05 inches of ET. So the purpose in showing that is that just basically to show that of water that is received on a field, applied or precipitation, nothing is 100% efficient. So irrigation is not 100% efficient. Precipitation is certainly not 100% efficient for the reasons that I mentioned before. So if 1.05 inches of the 1.2 inches evapotranspired, that means that 88% of that water, that precipitation was not suitable or not available for storage in the soil profile or recharging groundwater. And the reason I brought this up is because early on in this process, there were people that were trying to take credit for, or assumed, and it's just an education thing, that just because you get 1.2 inches of rainfall, or equivalent to 1.75 acre feet on their 20-acre field, they could go ahead and pump 1.75 acre feet. But that's not the case, because that water never went to groundwater in the first place. But a portion of it did, and about 12% of it did. So I hope that answers that question a little bit better. Now, in irrigated systems, you can turn on and off your pumps. You can turn them on for a certain duration of time, and you can match the demand of the crop, or the ET demand of the crop, which creates a much, much higher efficiency of water use than in precipitation in fields that just receive precipitation.
Okay, so they asked a follow-up, Joel. Said they're confused since the field is fallowed. Where did the 1.75 acre feet come from?
That's the amount of water that was consumed from the precipitation. That's where the water came from.
Joel, this is Aaron. I think to help clarify that, the 1.75 consumed is from the precipitation that gets evaporated off the ground or transpired by weeds or anything that might be of green nature on that property. Correct?
Yep, correct. Thanks for the clarification.
There for the attendee, what I've seen is there's no field in our region that has zero evapotranspiration, other than, I mean, theoretically sidewalk could get pretty close, but open ag field, there's nothing out there that has zero ET.
Great.
It would have zero ET if it didn't rain for a long period of time, like months and months and months, or close to it.
All right, thanks, Joel and Aaron. Another question, Joel, can you distinguish use of the water on the land if you have mixed use, such as a rural residence and small citrus grove on the same parcel?
Yes, we well, at least from the small citrus grove. So we delineate, I mentioned before, we delineate out, which means we draw a line, a digital line around the actual irrigated footprint of every field that's out there, 2 acres and greater, and many times less. So if we have a delineation or a digital polygon line around it, box around it, we analyze what's happening within that delineation. I'll have to defer to the GSA managers on how they look at rural residential efforts, because we're just that kind of do the ag side or the larger landscape component, which is by and far the vast majority of consumed water, obviously, and of houses and such.
This is Hagman. So in terms of a domestic part of that property, your demand would be your trees, your grass, and we're not looking at that at this time, but we do know there are larger parcels out there who have a lot of grass and a lot of trees for their pleasure that are irrigated. We'll have to figure out how we fix that in the future. And then your demand inside your home, 99% of that probably goes back in the ground through your septic tank. So we won't see that. And then in the east, we're making some assumptions about domestic demand and communities, and we're backing that number out, that amount of water out of the total water allocated to landowners who are irrigating their ground. So we have about 97,000 acre feet to allocate, and about 4,500 of that is consumed in the domestic or municipal industrial or in communities. So that means we have about 92,500 to allocate out for land use, for irrigation.
That's consistent with the Mid-Kaweah. We consider rural domestic de minimis for right now, and we'll be evaluating those larger rural domestics. If you've got, say, a large, like Mike said, a large landscape area that could consume a large amount of water, but we haven't seen that yet in the Mid-Kaweah GSA.
So I'm going to kind of take this a little bit off the cuff here, because I to be honest, I was sidebarring with some people who were asking some questions. But for domestic and for community water systems, we do have an ad hoc committee that includes some people that we have high confidence in for understanding those situations. One of them used to work for Self-Help Enterprises and is currently he's on the city council for Farmersville, and then we have Cal Water involved, and so we're working through those issues. But we definitely are treating drinking water as a priority, and they likely will be treated quite differently than anything that we've been talking about as far as our groundwater pumping cap.
Right, great. Thank you, Joel and GSA managers, for the thorough answer on that one. This one, I think we'll go to the GSA leads as well. Can you provide any updates on how dairy facility footprints are being treated?
So in the East Kaweah, we don't have a lot of them, but in the East Kaweah, we make assumptions about their demand through that 4,500 acre foot M&I piece of it. So we assume they're going to use a certain amount of water per cow. We make that assumption and remove that or place that demand in the 4,500 acre feet. We also have questions we've garnered for ranches that have cattle for grazing. It's the same thing there. We estimate water demand per cow, per cattle, and we removed or replaced that demand in that 4,500 acre feet. So collectively, our M&I, or municipal industrial demand, our dairy demand, which is a municipal industrial component, and the cattle ranch demand and home demand, all those things are part of the 4,500 acre feet.
Yeah, in the Mid-Kaweah, we've significant dairy footprint, so we are making some assumptions on top of dairies providing actual meter data. So you've got the dairy footprint itself with the cows on it having a demand, but some of that demand gets reused in the agricultural operation out in the field. And I know we've just reached out to the Greater Kaweah. Eric and I and our teams hope to work together, maybe to set for those folks that aren't able to give us meter data, we can model, like Mike's talking about. If you got a Holstein, that Holstein requires so much water. Yep. And that model is largely based on folks that already have the data, that have been doing it in other venues. And so we have a good approach lined out that'll be implemented within our water dashboard to help the dairies account for all their water supplies. Yeah,
like Aaron was saying too, we're trying to reach out to the people who understand those dynamics and can help us with those estimates. So David DeGroot with Four Creeks, who's also a dairy person, And then Jeff Van Den Heuvel with milk producers. We're trying to come up with those industrial operation estimates because the ET information doesn't quite work for them. But their ancillary operations, like their irrigated silage crops, are something that, at least for the grader, that we're still considering using the ET information for, because in large part, the majority of those properties are still irrigated, even if it's recycled by groundwater. So that's something that in our 90-day public comment period that we have for our particular rules and regulations is something that can be commented on.
Okay, a question from Angelica. This one would be for Joel. How can we find out where your official rain gauges are located closest to our properties?
Angelica, if Becca, if you'll go to my last slide, it has my contact information on it.
Yeah, and I think if I'm sharing, am I sharing now the slides?
You probably are. Let me look. Yeah, there you go.
Okay, great. So it should be on this one.
Angelica, feel free to call me or email me, and we really do appreciate grower feedback, and I'm happy to share with you where our nearest rain gauge is or how we might be in close proximity to your properties. So just reach out to me, no problem.
I guess while there's a lull, I'd really like to thank Joel for his time. As you can see, he's a busy guy. He's out there doing it as we speak. And really want to thank the Provost and Pritchard team for putting this all together for us. And it's running really smoothly. And I hope you folks are getting the information that you need out of these work products that we put together. So thank you.
Joel, why don't you tell everybody where you're at? Like, what are you doing right now?
Yeah, I'm in Soledad, and we're doing some ground truthing. I got a team of 2 people with me on ground truthing. That's what we live and breathe. So that's what we do. Yeah, driving down the road and dropping pins on an iPad, points on an iPad, what crop it is and its condition. And as I mentioned in my presentation, for calibration and validation of the at least land use models that we use, and then the same concept applies to ET, just use stations. And we have a crew that does that too. So we have one person, as I mentioned, we're going to have in the next 6 months, about 100 stations. We have one person in the valley, lives between Kingsburg and Dinuba, and his job is to paint the Golden Gate Bridge. So he starts at one station and he maintains that station and makes sure everything's up to snuff, and he goes to the next one, and then he goes to the next one. Then when he gets done with number 100, he turns around and does it again.
Starts over. Yeah.
Yeah, because we're a data-driven process, right? And our data have to be good going into our model. So we're very, very cognizant of that. We have 3 other people that build the stations, look at the data, make sure that we have flags in our servers. If the data are reading what we shouldn't expect, if it's 120 degrees and it's December, then we send our guy out there, say, fix something's not right. And we discredit that data, obviously, but we care a lot about that ground truth component. Yep.
Well, as somebody who in a former life worked in remote sensing, I just wanted everybody to hear that part of it, because the ground truthing and calibration part of it is really what separates, I think, LandIQ with other options like OpenET and others. So appreciate that.
All right. Well, Joel, Eric, Aaron, Mike, I'm not seeing any other questions at this time. We had a question. I went ahead and just typed an answer about how many attendees were on the call. So if anyone else is curious, we had just over 70 to start, and we're at just over 60 now for attendees. So just a handful. Thank you, Aaron.
Angelica just gave you some props, Rebecca, and I mean, I think you know that we all really appreciate the outreach that you guys do. You guys do a good job with these events, making it very easy for everybody to understand very complex issues. So thank you.
Yeah, of course. Thank you, Angelica and Eric, Aaron, Mike, Joel, and then of course Savannah and Trilby as well, who are a major part of helping put on this event, this webinar. So appreciate all of you and appreciate the attendees for coming this afternoon. We have one final workshop on this topic. It'll be very similar presentations. That is going to be on March 25th. That's next Friday at the International Agri Center in Tulare. So that's at 10 a.m. If there's anyone else that you know of who would benefit from attending, learning this information, if they have questions, please do let them know. But again, thank you for coming. I hope you all have a great day. And I think that's a wrap for today.